Hello, in this video we're going to derive the method of moments and the maximum likelihood estimates for the parameters of a beta distribution. This is part 2 because we had two videos, which I call part 1, that looked at to driving the equations for method of moments and driving the equations for the maximum likelihood estimator and setting them up for the Newton-Raphson method to solve for them. And here we're just going to copy those equations into R and run it and see what we get. So first we're going to collect a sample of size 100 and from a beta distribution, alpha 5, beta 3, store them in X. Now the method of moments estimator, you equate the population moments with the sample moments, specifically the first and second moments, and then solve for alpha and beta, and then those are your method of moments estimators. And that's what these are, the alpha 1 and beta 1, alpha 1, beta 1. And we'll look at how accurate those are in a second, but we're going to use those as our initial guess for maximum likelihood estimator. So A2 and B2 are going to be the MLEs for alpha and beta. And again, we use the maximum likelihood estimators as our first guess in the Newton-Raphson method. So I create a vector called parm, which is the parameters alpha, A2 and B2. And then F is a function of, that has two components, which I call F1 and F2, and which are essentially the partial derivatives of the likelihood with respect to alpha and beta. And then from that we derive the Jacobian, the inverse of the Jacobian. It's a 2 by 2 matrix, which is the partial derivatives of F1 and F2 with respect to alpha and beta. And again, you need to see the videos part 1s for more details on that. And then this step right here is the Newton-Raphson step, where you take the parameter, subtract the inverse of the Jacobian times this function, and you get new estimates for the F2. And then we take those and update our A2 and B2, and then you just repeat until they converge. And that's what we do here. And so in a sample size 100, the true alpha was 5. Method of moments estimate is 4.8. MLE is 4.6. True beta was 3. Method of moments estimated for beta is 2.9. The MLE is 2.8. What I want to do is highlight this code and just run it a few more times and look at them. Here, method of moments 4.7, MLE 4.8, 2.7, 2.79. Let's run it again. You can see there's some, it kind of ranges around the true parameters, and that's typical for these with a sample size of 100. Now if we go to a sample size of say 10,000, let's see what the estimators are. And here 5.03, 5.04, much closer, 3.0 something, so again much closer. Let's run it again. 4.9, 4.9, 3, and 3. So of course as the sample size increases, the estimates become more accurate. Let's try 5 million. Let's 1, 2, 3. Yep, 5 million. And the reason I'm going to show you 5 million is just how fast the method of moments estimates are compared to the MLEs. And actually there'll be two pauses. One, generating the data, and then the Newton-Raphson iteration step. And as I print this, you'll see those two pauses. There's the pause for the data generation, and here's the pause for the Newton-Raphson iterative method. It's going in a loop. It's only 22 times, but the vector, the data is 5 million long, and so that's lot. And so look at these estimates are very close. 4.999 rounded up, 2.999 rounded up. So again, very close. Well, that's all I have for today. Hopefully you enjoyed that. I sure did. Please like the video and subscribe so you don't miss the next one. And as always, I'm going to copy the code into the comments if you want to copy it into your program and modify it, improve it, or just play around with it. Thanks.